Okay, so in this example, I'm going to show you how to find the lowest common multiple and greatest common factor using prime factorization. So the first one we're going to look at is 28 and 60. So what you need to do is break it down into prime numbers, start by factoring them out. So factors of 28 would be 4 and 7. And 7 is a prime number, so we're finished. So then we'll just break down 4 into 2 and 2. And then we'll write it as a product of prime numbers. So that'll be 2 squared times 7. And that one's finished. Now we'll look at 60. So 60 we could break down into 6 times 10. And 6 is 2 and 3. And 10 would be 5 and 2. And same as the last one, we'll write it as a product of primes. So this would be 2 squared times 3 times 5. Now we take a look and we notice that we have 4 different types of prime numbers. We have 2, 3, 5, and 7. So we take a look at each group and we determine what's the highest exponent for each prime number. So for the 2 group, it would be 2 squared. For the 3's, since we just have the 1, it would be 1. For the 5's, since we just have the 1, 5, it would be 5. And then for the 7's, well, there's just the 1, 7, so it would be 7. So then we multiply them all together, and we get that the lowest common multiple for 28 and 60 would be 420, and that's our answer. Okay, let's try another one. So now we're going to look at the lowest common multiple for 6, 10, and 42. So break it up into prime numbers. So 6 is 2 times 3. So this as a product of primes would be 2 times 3. 10 would be 5 and 2. So as a product of primes, it's 2 times 5. And then 42 would be 6 times 7. And 6 is 2 times 3. So as a product of primes, it's 2 times 3 times 7. So now we notice that, again, we have 4 different types of prime numbers. So we find the highest exponents. So for the 2's, it will just be a 2. For the 3's, just a 1, 3. 5 is a 5. And 7 is 7. And so multiply them all. And the lowest common multiple for 6, 10, and 42 would be 210. Okay, let's try one for greatest common factor. So start off the same way, break it up into prime numbers. So 150 would be, what would that be? 50 times 3. 50 we could break down into 5 times 10. And then 10, 2, and 5. So write it as a product of primes. So it's 2 times 3 times 5 squared. Okay, now let's look at 420. So 420 would be like 10 times 42 would work. Any factors would work. At the end we should get the same. 10 is 5 times 2, and 42 is 6 times 7. And the last one we just need to do is just 6, so 2 times 3. Okay, product of primes would be 2 squared times 3 times 5 times 7. So for greatest common factor, we have to take a look at the prime numbers for each one and see what they have in common. So they each have a 2, they each have a 3, and they each have a 5. So then we take a look. They each have at least 1, 2. They each have at least 1, 3. And they each have at least 1, 5. So we take a look what they have in common, multiply those all together. So greatest common factor for 150 and 420 is 30. Okay, one more example for greatest common factor. So we want to look at 84 and 231. So 84 would be 4 times 21. 4 would be 2 and 2. And 21, 7 and 3. So write that as a product of primes is 2 squared times 3 times 7. 231 is 11 and 21. And 21 is 3 and 7. So as a product of primes, it's 3 times 7 times 11. So same thing, we take a look at what numbers they have in common. They each have a 3 and they each have a 7. So our greatest common factor will be that they each have a 3 and a 7. So greatest common factor for 81 and 231 is 21. So that's how you find lowest common multiple and greatest common factor using prime factorization.